Hello everyone, welcome back for the sixth video in our adventure through systems of equations. Now this is the last video I had planned for a two variable, two equation system. My next video will be three variables, three equations. I know, calm down. In this case, we're going to be doing elimination a second time with a second example. So let's get right into it. I know you're excited. So here we got the blue one. 2x plus 8y equals 6. Red, negative 5x minus 20y equals negative 15. So elimination, we need to eliminate one of the variables. In order to eliminate one of the variables, we're going to add the equations together. The only way adding the two equations is going to eliminate one of the variables is if they're opposites of each other. Spoiler alert, 2 and negative 5 are not opposites, neither is 8 and negative 20. So we're going to have to do some legwork here to make it so that they are opposites before we can go ahead and add the two equations together. Now, our toolbox gives us one thing that we can do here, which is multiplication. I'm going to multiply these equations by a number so that one of the variables are opposites of each other. I can multiply the blue equation by one number and the red equation by a different number. So that's going to be what I have to do here. The first video, elimination example 1, I eliminated the x variable, so just because of that, I'll go ahead and eliminate the y variable in this one so you can see how it's different but really the same. I could multiply the top equation by 20 to give me 160y and the bottom equation by 8 to give me negative 160y, but that's unnecessary, and my numbers will be a lot bigger than they need to be. I need to find a number that is both a multiple of 8 and 20. And that number, the smallest one that I can think of, would be 40. If I multiply the top equation by 5, the 8y times 5 would give me 40. And the bottom equation by 2, the negative 20y times 2 would give me negative 40. So that's going to be what I do. I'm going to multiply the top one by 5. When you do this, you have to make sure you multiply every term by that value, and the bottom one by 2. Now, since the blue y is positive and the red y is negative, I don't need to make the 5 or 2 negative because I'll end up with one positive, one negative, which will be opposites, and add to 0. So I'm going to go ahead and do this, multiplying everything in the blue equation by 5. So 2x times 5 is 10x, 8y times 5 is 40y, and 5 times 6 is 30. And do the same thing but different because it's 2 now for the red one. 2 times negative 5x is negative 10x. 2 times negative 20y is negative 40y. And negative 15 times 2 is negative 30. And now what we want to do is we want to add these two equations together. Now remember, I did this in hopes of canceling out the y. But what happened here for the x's? 10x plus negative 10x is 0. Those are going to cancel. 40y plus negative 40y, also 0. Those are also going to cancel. And 30 plus negative 30, also 0. Those are going to cancel. Everything canceled out here. We have nothing left but a bunch of zeros. Now, it doesn't mean we have nothing left. 0 plus 0 is 0, and 0 does equal 0. Now, remember, when we have a situation where all the variables cancel and leave us with numbers, even if they're 0, if the two sides of the equation are true, like in this case, 0 does equal 0, we get infinitely many solutions. Now, if we were left with something that's not true, like 0 equals 6 or 5 equals 8, then we would have no solution. So here, it is true, so infinitely many solutions. And we're done.